I'd like to talk about solving right triangles. First of all, I want to emphasize that the trig functions are defined for a 90-degree triangle. Your two other angles can be pretty much any angle you want as long as they're smaller than 90 degrees, but one of the angles for sure has to be 90 degrees. Recall this definition for our trig functions. If you have a right triangle, and we're labeling where theta is, then we can define our sine, our cosine, and our tangent as ratios of either opposite, adjacent, or hypotenuse. Sine of theta in this case is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. Do be careful, however, because I can draw a triangle that looks similar to this, and I can change the labeling. So there's a right triangle. Let's say that instead of looking at the angle in the left-hand corner, we look at the angle in the top. In other words, on this particular one, I'm looking at beta being the top angle. Be careful because when you label this triangle, your adjacent is the side next to beta, your opposite is the side opposite of beta, and then of course your hypotenuse stays the same. But do be careful because in that particular drawing, your adjacent and your opposite go in different locations because the adjacent and opposite are referring to where your angle originally is. Okay, now, the problems in this particular lesson are going to ask you to solve a triangle. And to solve a triangle means find the lengths of all the sides and the measures of all the angles. A guideline that I'm going to use as often as we can is never use rounded or not exact answers if you can avoid doing so. In other words, if you've gone and you've found that a particular side is 6.3752 inches, that's a decimal. In other words, it's not an exact measure, so try not to use that measure again. However, if you have, let's say you've looked at the angles and you found that the angles are 90 degrees and then 45 and 45, those 45-degree measures are exact, so we can use those particular measures again if we need to. All right. To solve a 90-degree triangle, there's different ways that we can do this, and usually what I've written over here to the side is I've said we're going to use a combination of these three different techniques. Number one, you can use trig functions to find missing lengths and even missing angles. Number two, you can use your formula x squared plus y squared is equal to r squared to find missing lengths. Be careful. You can only use these two tools for 90-degree triangles. Later on, we're going to be looking at triangles where one of the angles is not 90 degrees, and we can't use these two tools in that situation. And then number three, we can use the fact that all the angles in a triangle add up to 180 degrees to find missing angles. All right. I've also put an asterisk down here below. I said, see the comment above, which was the comment I had in red that was boxed in. In other words, never used rounded or non-exact answers. And the reason I referred back to that is when you're looking at these three techniques, if I'm never wanting to use rounded answers, one of these techniques may not work to be able to find what it is I'm wanting to find. In other words, let's say I found that one of my sides is 7.356 and so forth inches. I can't use the Pythagorean theorem to find my other side because the side I have found is a decimal answer. So that wouldn't be a good use of my tool since the side I found was rounded off. All right, from here, what I'd like to do is look at an example, actually a couple of examples. This one says solve the following. I have that one of my angles is 35 degrees. I have that one of my sides is 8. Usually what I like to do here is I like to label my angles. I will always label my right angle as a capital C. All right, the other two angles, I don't really care what we call those. I'll call this one down here A. I'll call the one up top that we've been given B. Now, the other thing that we will see is they will use small case letters opposite the angles. In other words, C is the right angle, so I'm going to call the hypotenuse little c. Okay. A the side that's opposite of A is the 8 that we were given. That's going to be little a. And then B, the side opposite angle B, is the side down here. And so we will see this labeling as far as, I guess, a standard way to label. Now, from here, there's one thing that I can find right away as far as a measure. Okay, I have that one side is 8, and then I don't have the other two sides. So right away, I can't find either B or C immediately. However, I can find angle A because I know that all the angles in a triangle add up to 180 degrees. I already know that one of them is 90, and I know the other one's 135. So to find angle A, what I will do is I'll take 180 degrees, I'll subtract off the 90 degrees that we have in one angle, and I'll subtract off the 35 degrees that we've been given for angle B. This will give me the measure of angle A, and this is 55 degrees. So now I have angle A. All right, now that particular measure is exact. In other words, that's 55 degrees exactly. I can use this particular measure again if I need to. All right, now from here I need to find sides. I can't use Pythagorean theorem because I only know one of my sides. And so here's what I'm going to do. I'm going to choose to use the 35-degree angle because that's what I've been given. And then I'm going to pick a trig function that involves the side I have been given, which is 8, and then one of the other sides that I want to find. Okay, so think about this. Here's the angle that I've been given. I want to use a trig function that involves 8. Well, that particular side in this case is the side that's adjacent to B. All right. And then let's say that I want to find C. Okay, so that being the case, if I want to find C, then I want to involve a trig function that uses the adjacent and the hypotenuse. Okay, and that being the case, I will use a cosine function. So I'll say cosine of 35 degrees equals adjacent over hypotenuse. Well, I know the value of the adjacent side, that's 8. So I have the cosine of 35 degrees equals 8 over, I don't know the hypotenuse, I'm going to use C because that's what I'm wanting to find. Okay, now that being the case, for this particular function, I need to solve for C. I'll multiply C by both sides to cancel the C out on the right side. So I have C times cosine of 35 degrees equals 8. To solve for C, I need to divide out cosine of 35 degrees. Okay, so C is going to equal 8 over the cosine of 35 degrees. Okay, we will enter this in our calculator. We'll find out that C equals 9.76619,671. Now that particular answer is not exact, and so we can't use that again to find other information. All right, so there's side C. Now let's scroll back up and look and see what else we need. So we found A, we found side C. All we need now is side B. Now it would seem natural, I have two of my sides now. I have my hypotenuse and I have the 8. But the problem is I do not want to use the Pythagorean theorem because, as mentioned before, my hypotenuse is a rounded number. Okay, so now what I'm going to do is I want to use angle B again, and I want to use a trig function that involves an opposite and an adjacent. Okay, that particular trig function is going to end up being tangent. So to find side B, okay, I can say that tangent of 35 degrees equals, and then scrolling back up, tangent we know is opposite over adjacent, so that would be B over 8. Okay. Now to solve that for b, we want to multiply both sides by 8. So we'll have 8 times the tangent of 35 degrees equals b. All right, we can plug in 8 times the tangent of 35 degrees on our calculator, and we'll find out that our missing side here is 5.601660306. Okay, and now we have solved our triangle. We have all the missing information that we need, our 2 other sides and our 1 other angle. All right, I'd like to look at another example. Okay, on this one, I want to solve this particular triangle. Let's give ourselves a little bit of extra room. On this one, you can see that different information has been given. Okay, in other words, I'm given 2 sides. On here, let's label first of all. Let's say we see here this is going to be angle C. So let's let this be little c. And then let's label these big A is that angle and big B is that angle. That would mean that 4 is little b and 7 is little a. All right. Now, first thing, we can find c right away by using Pythagorean theorem. All right, so a squared plus b squared is equal to c squared. A is 7, we square that. B is 4, we square that. We don't know what c is. All right, 7 squared is 49. 4 squared is 16. And then that would be c squared. We add 49 and 16, and that is 65. Okay, solve for c by taking the square root. We'll get c equals the square root of 65. Okay, so that one we now know. Now, the square root of 65, this is exact. So if we want to use that again, we can. All right, now from here, we need to find missing angles. To find missing angles, you want to obviously use a trig function, and then what we're going to do is use an inverse to get our angle by itself. All right, let's say that we want to find here angle A. All right. To find angle A, we can use any of our sides, so I'm just going to pick a trig function. Angle A, let's use tangent of angle A equals, tangent is opposite over adjacent, so that would be 7 over 4. To solve this for angle A, I need to take an inverse. In other words, taking the inverse of both sides would result in something that looks like this. On this side, we know those two cancel. That just leaves me with the angle. And then over here, tangent inverse of 7/4, we can plug that in on our calculator to get our result out. That result is 60.25518. And I used degree mode in this particular example, so we have degrees. Now that is not exact, so I don't want to use that again. So in other words, at this particular point, it's not a good idea to say, I know my other angle is 180 minus 90 minus this angle that I've found, because this angle is not exact. Right, so let's find the other missing angle. Angle B. If I look back up at angle B, let's say that we want to use tangent again. Well, in this case, in relationship to angle B, the side that's opposite is 4, and the side that's adjacent is 7. So we're going to be using a different order here. So tangent of angle B is equal to 4 over 7. Okay, that being the case here, we could take the inverse, tan inverse of tangent of B, tan inverse of this number. This we know just cancels, we're left with B, and then take the inverse to find your angle. And so on this particular one, you'll end up with 29.744881 degrees. And that would be the last missing angle. This concludes this lesson on solving right triangles.